Okay, Bismillah Rahman Rahim. Let's get started, right? So, what we have to read today? Huh? The Sayat, because we have read about the whole candle. Okay, now we need to read about this thing, which will ignite it. So, this is what is called as IP addressing and subnetting. Okay, we have a physical address and we have a logical address. Now, what is meant with the physical address and what is meant with the logical address, and uh, why we need addressing in the first place, and what is subnetting and what is subnet itself? Okay, in a computer science, you will understand the subnet has a two meanings. One meaning is, which I have told you in the beginning classes, if you remember, is that if we have, for example, a host here, a computer, whatever it is, laptop or whatever it is, it could be mobile phone, it could be tab, anything which uses the end system, which is using something, internet or something else. Then we have another guy here. There could be a lot of things. There could be LANs, we have a LAN here and all. Then basically they are all connected with either routers, or we have bridges, we have seen the switches, we've seen a lot of stuff, okay? And the connection wires, definitely, which connects these guys. Getting me what I'm saying? Now this part of the network, which is consisting of the wires, okay, and the switches and routers and gateways and bridges and all that, excluding the end systems. If you keep the host part out, this is called as a subnet. But today what we're gonna deal with subnet is something different. So it has two meanings. Okay. The first, the subnet was used for these things, but now later on we got the next meaning of the subnet. So it's nothing to confuse. We have to see what is the context to get out what subnet means actually. Okay, which subnet we are talking of. So the second meaning of the subnet basically is that we have a network. For example, we have a network. For example, this is my router, and with it we have some computers attached to it or something like that. We have a this was my network. Okay, now I want to break this network into subnetwork. Now I'm breaking network into the subnetwork. From this subnetwork we got a short term called subnet. This is what we deal today. The subnet means to divide a big network into the small networks. Why we do that? We will see that, because if you want to get the idea why we do that, because if we have, for example, some 100 computers, okay, we got an office and we have 100 computers. Now 100 computers means that we need to have a big, for example, these are my 100 computers. Look here, we have 100 computers, okay, lined up together and tied together with some wire, right? Say for example we have got a big wire which is connecting all of them together, and now you can understand there's a hell lot of contention between the two. Say for this is 100 computers or 200 computers, is it? Now there is a contention, there will be a lot of collisions. Even if you use CSMA CD, okay, still it will be, if you use carrier sensing, there will be some lot of chaos on it. To manage it will be very difficult because we have 200 computers on a single connected to a single bus. So better option is to break all these, say for the 200 computers, in a small networks with their switch in between. We have a switch, and say for example this network is connected to this, right? Then we have another switch which connects to the another network, for example, and maybe this from this to this switch we connect with this. Are you getting me? So we can have switches which can divide this one large network into the sub networks, and this is called as subnetting. Okay, this is called what? Subnetting. And we'll see what is the how is the subnetting being done. Are you getting me or not? So we get the first the logic of the addressing. If we have addressing, for example, how we do the addressing? Okay. What I'm telling you is, look here. For example, we have a system here. The second system is here. We have 3-4 systems here, for example, tied together on a bus. Say maybe we have a hub. If we have a hub that is passive, we know, which is connecting all of these guys together. For example, we could have a hub. We could have a switch. Okay. But we need a router if we have to connect these guys with the external network. If we have a local network, there's no need of router, right? Is it or not? Because router works on which layer? Network layer. Only Sabrine is telling me it works in network layer. And when you have nothing outside your network, the local network, then there's no need, because if we say IP and network layer, it is basically to connect two hosts, okay, right? And particularly if they are not on the same network. Particularly if we have now we have still here the TCP/IP, for example, software loaded, right, which has all the layers intact. But if it is on the same network, we have a job to up to the physical data link layer only, right? We need only data link layer to do the transfer between the from this guy to this guy. Now what happens is we have the two addresses here. One is the physical address, which is the actual address of the machine. What is that address? That address is basically, you know, burned into the network card, whatever the interface you have. For example, we have Wi-Fi here. The Wi-Fi device will have an address which is 40-bit long, 48-bit long, what is called as a MAC address. MAC, you know, all of you have read a lot of things on it now, okay? No need to explain it. So 48-bit MAC address that's burned into the network card. We have two in this laptop. If you see, there are two network interfaces. One is the Wi-Fi 802.11g and one is the Ethernet 802.3. So Ethernet also has its MAC address, which is the port address. Exactly knows which address it is, because it has to be unique address. Because if in this class I'm talking to a particular guy called Shadab, he has a particular address. Now if we have two Shadabs, there will be confusion. If I'm saying something, if sending a packet to the Shadab, now if I have two Shadabs, there will be confusion. So we need to have a unique address, right? That is why in your database, as we read, we have a primary key. Because if you want to address particular thing uniquely, we need something unique. And this MAC address is the unique. In fact, sometimes it's called unique to universal, because if any device you get in which has its MAC address, okay, like your Ethernet card or your Wi-Fi router, they are worldwidely organized. They worldwidely, NIC is a which sets the framework for this. It sets a unique. But sometimes it's not unique. We can understand. We can trick away with that. Okay, if we have in a particular, for example, India, we have America, and then we can trick out with that. How we can use reuse. So this is, but how we do that, I will take it off. I will take it here that it's unique. I will take the discussion off here. I will say this is unique, but you will remember it's not unique. Actually, it's a quasi unique. I could think it's a quasi unique, not exactly unique. Okay. Now we'll consider here it's unique. Now if you want to see what is the MAC address of your device, you go to the start menu. Okay, you set CMD command prompt to get in the command prompt. Okay, here we go. It's not getting me. Here with the command prompt, right? And in the command prompt, what I'm gonna do is I will say IP config, IP configuration / all. Now it gives a whole bunch of stuff, and I'm not interested in all the things, but I'm interested in Wi-Fi and my Ethernet. So Wi-Fi is this wireless network connection, and we got an Ethernet adapter. And you can see here entry physical address. The physical address is the actual physical address, which is burned on it. It will not change. It's unique to it. It's burned by the company into its ROM. Okay. So that is, if you could see here, these are 6 pairs. Okay, and this is hexadecimal. One hexadecimal digit takes how many bits? 4. 4 bits means one hexadecimal. Is it? Because hex starts from 0 up to, yes, 15. So total is 16 digits. So definitely 2 to the power 4 is 16. So we need 4 bits to represent. You know all these things actually, huh? For the beginners, they may be confused because you have done a lot of digital electronics and a lot of stuff you have read. So you know that. So it is a 4 bit each hexadecimal digit. So it means if it is a 6 pair, that means 12. 12 into 4 is 48. So 48 bit address. Okay. Now if you go see the Ethernet local area connection, it also has its physical address here. Okay. This is in a hex, and this is what they have given it to it. Are you getting me? It's burned into the. In fact, it's a two. It has a 2 parts. Okay, this part and this part, and one part identifies company and one part I will not discuss that. I just say that this is a physical address, the actual address what your device can be identified by. It's a huge address, isn't it? 16-bit, because it has to be huge because it has to be worldwide. It need to be unique. Now, when we are talking about the if it is not a hub, it is a router. It is a router. I told you when I explained routers, hubs, and etc. It remembers the MAC addresses. Do you remember that? I said it remembers the MAC address. These are the MAC addresses. Because every device will have its MAC address. Say for example you are connecting it to the Ethernet. You are connecting these guys to the Ethernet. They have an Ethernet card, will have this MAC address, 48 bit. So it's remembering it. And also, say for example we have a Wi-Fi device here, wireless, a laptop here, for example, which is connecting to the, because it has also the antenna, for this is the antenna and it's connecting with the Wi-Fi. This is my laptop, for example, and it's connecting with it, right, with the Wi-Fi, with the radio. As you could see here in the D-Link, we have, this is my D-Link router. We have a wireless on it, and on the back we have the ports. You can connect to the RJ45 cable from these ports, because I told you it's a switch cum router. So switch on the back, which can connect to the what? To the Ethernet cable, or a laptop using Wi-Fi, or any device which has a wireless interface. Getting me? So it does remember the MAC addresses. Now, if this listen, if this guy has to send a packet to the device which is inside the LAN, inside of this LAN, if you have to send, say, this to this guy, say for example this is device A, okay, I want to send it to the device B or C or D or E, and they are tied to it. So then we do not need a router. Okay, we do not need a router because we only need to know what is the MAC addresses and all. But we do not deal with the MAC addresses. These 64, how much was this? 48 bits. These 48 bits MAC addresses we don't deal with. We deal with the logical address. Okay, logical addressing means we say like 0, 1, 2, 3, 4, something like that, which becomes easy. Then it is the job of this switch, which converts from this MAC address 1. If I say this is 1, I call this is a 2, 3, 4. Now it is this address. It has inside a table which says 1 means this MAC address, 2 means this MAC address, 3 means this MAC address, and so on. But it's not exactly 1. We can say 1 because if, now question is, if we have to send a packet which is on some other network, okay, then I need a router in between. Say from this is a router, okay, then this is another network here, and I want to send to this guy. Now my MAC addresses will be of no use. It will be the IP address which will be of use. Okay, MAC addresses we need internally to the network, but IP addresses I need that's worldwide. So IP addresses again need to be unique. Okay, so IP addresses which we give to the unique, it should be also unique, but it is again not unique. We reuse it and we do a lot of tricks over it. But the basic idea is we have to, but at a time a machine, okay, we'll see internally we can reuse the network addresses and all, IP addresses and all, but the main idea is, because if you have to send some email to your guy which is in Alaska, okay, that machine need to have a particular address. For example, if you are coming to my house, this comes in India, this comes in, for example, Kashmir, then Srinagar, then Sora, then Lene, house number 44. I'm telling you exactly. So house number 44 is the host address, what we say in a typical term. Because this house I'm living in, this is my house number 44 is my host ID. It's exactly my address. The rest what I'm talking about, India and all, this is a network address. Where I am exactly, that is the wire. What we can say, this is the wire. That's the wire address. Then it will go from the router to router and go to, and it has to come here. For example, this laptop. So we need exactly what address. So only saying 1, 2, 3 it will not work. We have to say exactly which country, which address, everything is to be specified. So that that means if I'm using this time internet on my laptop, it will have a unique ID which will be nowhere in the world. This is the basic concept. Later on we will see that maybe we'll do some tricks on it, but this is the basic idea. So we need a router which can send it the IP addresses. Are you getting me? So how is IP address being assigned? What is an IP address? Okay, and in this IP address we will need to have two things. Remember, in IP address we need to have two things. One is the network address, and one is the second is the host. Forget about MAC. I'm not talking MAC. I'm saying like in the world, there's a country called India, and there's a state called JNK. In the JNK we have a city Srinagar. In the city Srinagar we have a town Sora. In Sora we have the say for the Shah Faisal colony, and then we have lane A, house number 44. Lane A doesn't belong to me actually. It is not my property, isn't it? The country, the state, this is not my property. That's the network address. Okay, host address is the house number 44 where the person is living in. That is my host ID. So this IP address need to have two things in it. One, network address, and another host address. So I need to have basically in the IP, in the internet protocol, I need to have two parts. One is telling me net ID, what is the network ID, where it is exactly in the world located, and second is what? The host ID. Because if I somehow I got network ID and I reach it here. Listen, I reach it here. But here I'm having some 1, 2, 3, 4 hosts. So I need some bits to reserve here, which can give me address to the host 1, 2, that was 0, 1, 2, 3, 4 I said, right? But how many bits I have here, it will tell me how many hosts I can have. If I have 2 bits, if I have 2 bits reserved for the host, how many bits? So from the 2 I can name 00, 01, 10. So I can have 4 hosts. I can name this as 00, I can name this as 01, this as 10, and this as, if I have only 1 bit left for the host, I can have only 2. 2 to the power 1 is 2. That means 0, I will name one host as 0, another host as. And if I have 3 bits, if I reserve 3 bits for this, it can run from 0, 0, 0, 0 to 1, 1. What is that? So I can have 8. But out of this 8, for example, I have 8. Remember one thing. Out of these 8 we will have like 000. What is that? Now this part and this part we don't use. This means this host. This means the host itself, this host. But we will not use it to. This means this 00 means this network. This 00 means, for example, I'm talking of. I have reached to the network here. This is a switch, and with it we have a network. We have some hosts here. Now we need to have how many hosts here? That depends on the number of bits. But if you have 3 bits, that doesn't mean we can have 8 hosts. Because yes, we have 6 because this guy means this network. This network. So it doesn't. I cannot use it to name this device. Okay, and one-on-one means multicasting. It's used for broadcasting. Sorry, used for about. If I have address of one-on-one, that means send to all of these networks. So they have special use. This and this has special use. So I can have 6 devices. I can name this device as 001. This as 010. That means 2. I can name it as a 3. 011. Then 4. In fact, yes, I said here 3. You're right. Then 101 is 5. Then another device which is 6. 110. Right? If we have 3 bits in a host, part of the IP address, I can have 6 networks. That is, then in the general we can say 2 to the power n minus 2. Why minus 2? Because 000 means this network, okay, and 101 means broadcast. I don't use this for naming a device. Are you getting me what I'm saying? Sure. So on this side I'm having the net ID, on this I'm the host ID. I will discuss that. We'll discuss it. We'll come back and discuss again. When the internet started, basically the addressing of internet is like it is not a good what they have it's not well planned, I can say, because internet developed, it was not, they couldn't imagine that so much of computers will be tomorrow connecting with the internet. They had no idea about it. So the addressing they started with was something which is just getting depleted. We don't have any addresses left. So we are using different techniques to extend it, and now we are saying that we will actually discard it and we get the new addressing. So the addressing we had was called the IPv4 version 4, IPv4 addressing, okay, which is a 32-bit addressing. How much? In a 32-bit you get a 4 billion. This is the 4 billion address space, because 2 to the power 32, right? This much of addressing we can have, but not exactly 2 to the power 32, because some will be used for control and all. Okay, like we said, 2 bits in a 3-bit, one for this network and 1 for the broadcasting. So we use many techniques to extend it IPv4. One of them is the subnetting. Also, one of them is the using the ISPs, internet service providers. So we have ISP. We use these days. We do not buy directly the IP address. I'm not having directly my IP address directly. That's me. Rather, it is bought by the ISP, internet service provider, which is the BSNL here, and then they do the subnetting. You will be confused because you don't know what is subnetting. We will come to that. But you can understand here that we have the new, that's called that's AKA IPv6, IPv6, AKA it's also known as it's also known as IP new generation, NG version 6. Okay, our software. If you look at the softwares you have today, TCP/IP softwares, they are already having IPv6 in it, but it's not being used right now. Right now we are using IPv4, but the future is with the IPv6 because it has 128 bits. How much? 128 bits is a huge number. You could imagine, because if it's a 32 bits, 2 to the power 32 will give the 4 billion, and 128 will give you 340 undecimillion. So undecimillion is such a number. Even if you have something called a trillion, okay, that is a huge number. Now it's undecimillion. Undecimillion is actually deca, 10. Undeca means 11. Dodeca means 12. So undecimillion. So 4 billion. It is undecimillion. So it's around. So you could understand how much a big number it is. It is unimaginably big. It's a mammoth number. So that means we have a huge IP addresses that we can give everybody in the world one IP address. Because when internet was developed, we had never an idea, right, that everybody will be using internet like this. Now internet is growing. Okay, everybody is on internet. So one day will come, every human being will be using internet. That means one day will come, we will have every human being one IP address. So we will identify uniquely every human being with an IP address. That day will come. Every head in a universe will have a tag. So then we will not, maybe we don't use the names. We will use the IP addresses, who you are, in your identity cards and your passports and all. You will have an IP address as your identification. That will be a good thing because it will be used for everywhere. Your passport, your identity cards, your admission numbers. You don't have to use who, and it will give lesser frauds. Because no two person can have a IP address same. The day will come like that because everybody is using internet and it is getting necessary now. Okay, because the revolution what we are living in is called the information revolution. Okay, so everybody will have a database who you are. There will be a chip. This is being implemented in many places now. Now you have a chip. Okay, like you got the iCards in a company. You have an iCard. There is a chip on it, on the iCard. That chip has your all database, and when you enter into the gate is actually identifying you. You have a card, it is identifying who this guy is because it's getting all the information from this. And then you have maybe for checking you have the retina checks. They see the retina and they check. You put your eye in front of a camera, it can check it is you. Yes, exactly, it is you. That is how they operate in the companies now. Okay, the gate will automatically open. There is no gatekeeper. The gate will automatically open because of you. Now maybe they will put a ROM inside our brain, so nowhere to go. So it will be just a small chip behind the skull. This skin, put in anywhere, and you are done. So no problem. You have to do nothing. Even you shop, the credit card and all this all there. This is not a story. This is the fact. You have to understand that how brilliantly the computer science is going on. It is totally changing our life. Are you getting me? These things are happening, by the way. Anyway, so I was talking about the IP addresses. So IPv4 definitely we are depleting it because it's only 32-bit. It is only it's already obsolete now. We have already started to think around it because हमारे पास इतने एड्रेस है ही नहीं. हम already खर्च कर चुके हैं addresses, and the way we devised the IP address thing was also not a good. And what was that way is called the classful addresses. What's it called? It is called class full IP addressing. Basically today what we are doing is what's called classless IP addressing, what's called CIDR, classless interdomain routing, CIDR. I will come to it, but first let's discuss classful IP addressing. So what is the classful IP addressing? It started when the internet started. It started when the internet started, right? We divided this 32-bit address because I told you we have 32-bit address, IP address. Okay, and out of it we have to say what is the net ID and host ID. And one more thing is, now what is the class of the ID? What is the class of your IP address? One. Okay, Then second part is what is the network ID and host ID. And they broke it into the 5 categories. They say as like class A address, class B, class C, class D, and class E. Okay, we have these classes A, B, C, D, and E. Getting me? The class A was given to the big guns, the guys who started internet actually, like your IBM, like your Harvard University, okay, Bell Labs. These the guys who started internet actually, the big companies, they were giving the class A address. And then next to them, they are also the big companies. They get the class B address. They got what? The Microsoft comes in the class B. In fact, Microsoft is the biggest big company, but it comes in a class B, right? Because it was not the pioneer in the internet technologies. Microsoft come actually later, but IBMs and all, they were somebody who have developed all these things, the computers and all. The small companies and all, okay. In fact, the we people, what we are given is a class C address. We have small companies and all, you give C address. And D is not given to anybody, it is used for multicasting. Okay? Because we know there are 3 things. One is called a unicast, then there is a multicast, and then there is a broadcast. Broadcast means like I'm talking here, everybody is listening. Multicast means now I talk to a particular group. Out of you, my packet will go only to the particular group, not all, but not to a single person. It is not a point to point. Multicast is not a point to point, but it goes to a particular group, but it doesn't go to everybody. Broadcast means no, it go to everybody. Whatever is on the network, it go to the everybody, right? And unicast means definitely the point to point. These all 3 are for point to point, unicast. If we see here, I have to make a table out of here. I will say here, because we have to say a lot of things about it now. Now these guys are this is for multicast. Sorry, unicast. Huh? This is also unicast. This is also unicast, and this one class D address is basically for the multicast. And broadcast, we know if we have all ones, it means broadcast. If we want to broadcast, we'll put all ones in IP address, right? On a host side or whatever, on a host side. And the E address E is used for future. But basically the future, what is, there's no future in it, because you said the E will be used in the future, but IPv4's future has gone. Okay, because now we have IPv6 version 6. It's also called IP next generation, NG. You are getting me or not? Are you getting what I'm saying? Sure. Okay. Now I'm telling you there are 3 parts. Now we have divided into the 3 parts this IP address. One is the class. What is the class of your address? And what is the host ID and what is the net ID? I should say net ID here, right? What is the net ID and what is the host part? Host part, you understood what's the network part and host part. Network means all those wires and routers where it has to go. But host means exactly the guy which we're talking of. And the bits in the host part means how many hosts you can handle. The bits in the net part means how many networks you can have. How many networks you can have. Now, if we have in the IP address, okay, if we have an IP address here, the first bit as a 1. Okay. What else? If you have the first bit as a 1, this means it's a class A address. It's what? If we have like this, in fact, it should not be 1. If say 0, sorry, not 1, 0. If we have 0 in the beginning bit is 0, the last bit is 0. The first bit, first most significant bit, MSB. Out of the 32 bits, if the most significant bit is 0, okay, then it is your what? It is your class A address. But you should also understand this 32-bit. First, before that, we discuss this 32-bit. Our computer understands binary, right? But what we do is how to represent IP. Our computer understands what? Zeros and ones. So to take a huge string of zeros and ones, all these 32 bits, but we will be confused to work with 32 bits in a huge way. This will be really tough on our part. So we had divided this 32 bit into the octets. Octa means 8. So how many 8s will be in 32? 4. So we are divided into 4 chunks. 1, 2, 3, and 4. Right? 8 bits each. 8 bit here, 8 bit here, 8 bit here, 8 bit here. Now if you're present, you can represent it in a binary like 0, 0, 0, 0, 0, whatever. 1, 2, 3, 4, 5, 6, 7, 8. I'm saying like this. So you put one here, like this. And then I'm having another guy, another here, the next 8 bits here. But I'm dividing it. Basically, computer will take it as single 32 bits. But we are dividing for our easiness into the 8 octets. So first octet, second octet will have something. Say for example, 0, 0, 3, 4, 5, 6, 7, 8. And say from this is 0, 0, 0, 0, 1. One, 2, 3, 4, 5, 6, 7, and 8. What's happening here? Okay. Now this is my bit string, but I have divided into the 8. And we do not represent, when we work on it, we do not work on binaries because it will be tough on our part. So what we do is the representation we do is what's called as decimal dot notation. We do not represent a binary. What we represent is called a decimal dotted representation. Yes. So we will convert this simple thing is we convert this into the decimal part. So what is this number? This will be how much here? Because 8 bits from 0 to 7 is 8 bits. 8 bits means 2 to the 1, 2, 4, 8, 16, 30, 64 and 128. Is it 8 bits? 1, 2, 3, 4, 5, 6, 7 and 8. Yes. So it's 128 plus 1. That's what? It should be easy for you guys, I think. What is this number equal to? I don't think this should be tough on you because subnetting and all, newcomers who go for CCNA and all, they find it very tough and they think they have learned something, but this is very easy for you guys. 1, 2, 1 and 16. 16 plus 5 is 21. What is this? 1. What is this? 1, 2, 4, 8 and 16. So we represent this address as like this: 129.21.1.17. 129.21.1.17. This is called as decimal dotted representation. Right? This is how we use it. We represent in decimal dotted. Decimal, because decimals is what we use all the time, so it will be easy on us. But computer, it will be converting into the binary later on. Let it convert to binary, it will work itself. Sanu ki load hai. You getting what I'm saying? Okay. Now coming back to the classes. Now, because we have 4 bits, okay? We have 4 bits. 1, 2, 4 octets. Sorry, we have 4 octets, right? 8 bit each. So you could say there are 4 bytes. That makes 32 bits. So I will make it a 4 bytes like it. We have a first one is, this is the first byte, this is second, this is third and fourth to the everybody, right? Now then, if the first bit is 0, okay, consider it to be the A address, A class A address. It's the class A IP. If it is, the first bit is 0. if we have like this 1 0, this one is what? Class B address. Okay, if we have 1 1 0, it is class C address. I'm saying then there is other bits also, right? But I'm talking about if we have the in the as a prefix 1 0, as a prefix 1 1 0, it's class C address. It is like this. And if we have 4 1 0, it's class E address. You getting me? Sure. 4 ही बिट कहाँ? 8 है ना आपके पास, ये ऑक्टेट्स हैं, ये ऑक्टेट्स है ना आपके पास. You have 8 bits each. Are you getting me? So this is identification of class A. If you want to identify is this class A or class B address, you will see the beginning bit. If it's beginning bit is 0, it means okay. So if we say the range, if you want to see the range, what is the range now? What is the range? It starts from the 0 because 0 means 0. Okay, and we know total we have 255. Total we have what? 255. Is it or not? Where from the 255 come? Because in a particular bit we have a 8 bits. 2 to the power 8 is what? 256. So 0 to 255. 0 to, right? 2 to the power 7 is 128, right? 2 to the power 8 is what? Then 5 and 2 and 1024, right? So 2 to the power 8 is how much? This is the first year stuff here. 0 to 255 is total address, right? Let us see what is the class A taking the range. So what is class B? What is the address class B will start? 1 0. That means 1 0. What is this 1 0? This is basically the इस 8 बिट जो आपके पास है यहाँ पे, इसका जो प्रीफिक्स है वो 1 0 होगा, बाद में पता नहीं क्या होगा. ठीक है, ये सारे 0 भी हो सकते हैं और इस सारे 1 भी हो सकते हैं. 1 2 3 4 5 6 7 and 8. लिसन, ये जो मेरा ऑक्टेट है, मुझे ये 1 0 होना चाहिए. रेस्ट क्या है मुझे पता नहीं. इसमें मिनिमम आ सकता है 0 0 0 0 0 अप टू 1 1 1 1 1 1, राइट? एंड दिस शुड बी 1 0. बट इसको छोड़ के ये 1 0 ही होगा अगर क्लास बी आपके पास है. बाद में आपको ये कुछ भी कॉम्बिनेशन आ सकते हैं फ्रॉम 0 0 0 0 अप टू द 1 1 1 1. वो हो सकता है 0 0 0 0 1 0 0 0 1 0 0 0 एंड सो ऑन. इट कुड बी अप टू 1 1 1 1. यू गेटिंग मी? श्योर? अच्छा, तो अगर आप इस नंबर को देखेंगे, व्हाट इज 1 0 इक्वल टू, व्हाट इज दिस 1 इक्वल टू 1 इक्वल टू, ये 1 क्या है? 1 2 4 8 16 32 64 120. so it is 120. so basically class B will शुरू कहाँ पे 128 पे. it will get started from 128 up to whatever, up to अभी देखेंगे. पहले हम शुरुआत कहाँ से करते हैं वो देखते हैं. so it will start from 128, right? so if you have any address which is starting above the 128, it is basically the class B. and if somebody is a 0 to 127, definitely then it will be up to what? It will definitely be up to 127 then, right? क्योंकि 128 से शुरू होता है क्लास बी. इसकी रेंज कहाँ तक होगी? लेकिन 127 नहीं होता, 127 नहीं होता. टेक्निकली इज अप टू 126, क्योंकि 127 हमने रिजर्व रखा है फॉर लूप बैक. आई विल टेल यू व्हाट इज दैट. विल डू इट. ये याद रखने का है. 127 गायब है यहाँ पे. 0 to 126, टेक्निकली इट इज 127 बट इट इज 126 because 127 we have reserved, we are not using it for addressing, right? 127 जो आपका है उसको खास काम के लिए रखा गया है. we will see that. अच्छा, ये तो B होगा शुरू 128 से. कहाँ तक होगा वो देखते हैं. अगर आप कहाँ तक निकालना चाहते हो फिर यहाँ तक होगा. सिंपल बात है, यहाँ तक होगा. ये जो है ये आपके पास जो है ना, because 1 0 plus these all ones. now if you want to see what is this, a 1 2 4 8 16 32 है. 32 plus 31, right? 63 प्लस आप ये कितना था यहाँ पे 128. सो 128 को आप कितना ऐड करेंगे, दैट विल बी 191 डेफिनेटली. सो द रेंज अगर आप देखना चाहते हो ये 191 तक होगा. अच्छा, ये कहां से शुरू होगा 192, बिकॉज 128 प्लस 1. फिर से मैं आपको बताता हूँ, देखो क्लास सी जो एड्रेस आपका है यहाँ पे, मेरी बात सुनो आप, फिर आप बोलोगे नहीं, अगर इस तरह आपने पढ़ा तो फिर बोलोगे नहीं आप. ठीक है, विद द लॉजिक क्या हो रहा है. देखिए हमारे पास जो पहला ऑक्टेट है, ओके, हमें होना चाहिए क्लास, किसकी बात हो रही है, क्लास सी की. इट शुड बी व्हाट 1 1, इज इट 110, जिसमें यहाँ पे दिखा चुका हूँ. रेस्ट हो सकता है आपको 1 2 3 4 5 6 7 8 बिट. रेस्ट आपको ये 00 हो सकता है या कोई भी कॉम्बिनेशन हो सकती है. इट कैन रन फ्रॉम 00 अप टू 1 1 1 1 1. लेकिन ये वाला हमारा होना चाहिए 110. तो शुरू कहां से होगा, यहां से खत्म होगा यहां तक, है ना. इसके दरमियान इसकी रेंज होगी. नाउ व्हाट इज दिस, दिस इज 128, दिस इज हाउ मच 128 प्लस 64, दैट इज 192. तो ये शुरू होगा कहां से 192 से, क्योंकि ये खत्म हो रहा था 191 तक, ये होगा 192 से, है ना. अच्छा, ये कहां से शुरू होगा फिर बताओ 192, ये तो हो गया. अभी 3 1 है ना, ये 128, ये 64, ये 32, यानी कि 192 को 32 ऐड करो 224. सो यानी कि ये कहां खत्म होगा क्लास सी एड्रेसेस. समझ आना, किसी को कोई प्रॉब्लम बता दो. अच्छा, क्लास डी होगा 224 से शुरू. क्लास ई कहां से शुरू होगा, अब 224 को और एक 1 ऐड करना है, क्योंकि ये एक 1 बन गया. कितना है ये, शायद यू विल टेल मी only शायद will tell me what is this number here, what should be the number. हाँ, अब ये 1 ऐड करो, ये 128 था, ये 64 था, ये 32 था, तो ये कितना होगा, सिर्फ शायद से बोलिए. हाँ, कैलकुलेट एंड टेल मी क्विकली. 240. Why are you confused? It's 240. So it should be 239. If I am saying here 240 because 239, but what will be this? Why is 239? Because this will run from 1110, then all zeros, right? Like this. This will run 1110, then others are also zeros. Huh? This is the net. This is about the class. This will tell me what the class is. Huh? 5 6 7 8. From this place, this is how much? ये आपने कैलकुलेट किया, ये कितना है अभी जो किया, ये को ये था आपका 128, 64 प्लस 32, व्हाट वाज दैट 191. कहाँ तक होगा ये, जबकि ये सारे 110 या इसका है, इसके हम कुछ नहीं कर सकते, लेकिन बाद में सारे क्या होंगे. ठीक है, तो ये कितना बड़ा नंबर बनेगा, व्हाट इज दिस नंबर इक्वल टू 1 2 4 8 16, 16 प्लस 15 31 करो ऐड 191 को. नहीं हमने गलत किया यार, गलत कहाँ पे किया हमने. हाँ 1 2 3 4 5 6 7 8, हाँ तो गलत किया, एक ज़्यादा किया था. 1 2 4 एंड 8, 8 प्लस 7, दैट्स हाउ मच 15. 191 को 15 ऐड करो, ये 191 है ना. आप 191 को 15 करो ऐड, ये कैसे, फिर हमने गलत कहाँ कर रहे हैं, हमें समझ नहीं आ रहा. 1 2 3 4 बिट्स तो हमारे पास है, बिकॉज इट इज 1 1 1 0, राइट. इज इट 1 1 1 0, हम तो ये गलत कर रहे हैं ना यहाँ पे. 111 ये क्या है ये? What is this number equal to first? Is it 191? You told me wrong.
224
ये कितना है भाई? ये 128 है प्लस 64 प्लस 32. ये आपने मुझे ये नंबर बताया ना गलत 191 वाला, बाकी हम ठीक कर रहे हैं. So what is this equal to? This is 14. 6 plus 4 is 10 plus 2 is how much? 224 plus this much numbers, that is what? How 16? 15. 8 plus 7.
0 to 5. 0 to 15.
नहीं नंबर कितना है ये यार? क्या तू कंफ्यूज है? This is 1 2 4 and 8. This is equal to 15. क्या एक लेते हैं यार? 5 plus 2 is now. So 239 is the range, cutting point. अच्छा E का हमने कहा कि इसका क्या होगा? अगर E क्लास आप देखोगे, E क्लास मैंने बोला क्या होगा? 1 1 1 2 3 4 5 6 7 और यहां से कहां तक? 1 1 1 1 0 up to, is it? Because this will range from like this. आपका ये कॉमन है 1 1 1 1 0, लेकिन ये रेंज होगा 0 0 0 from 0 0 1 0 1 0, right? All combination 0 1 1 1 0 1 0 0 1 0 1 1 1 1, और ये यहाँ पे लिखते जाओ, है ना? यानी कि यहाँ से यहाँ तक. ये कौन नंबर है बताएगा मुझे? खाली शौकत. व्हाट इज दिस इक्वल टू? हाँ, ई क्लास की बात करें. ई क्लास का वो वहां से कॉपी से मत देखो, कैलकुलेट करो. दिस इज 128 प्लस 64 प्लस 32 प्लस, ये फर्स्ट ईयर का स्टफ है यार. यू आर इन फाइनल ईयर, यू शुड बी डूइंग इट नो विद इन अ सेकेंड्स. कितना होता है ये रकम? ओके 240. व्हाट इज दिस इक्वल टू? बिकॉज 240 तो ये आया हमें, अभी किया हमने कैलकुलेट. प्लस करना है ये कितना है? 7. दैट इज व्हाट? वेयर इज 247 नाउ? Yes, but we have 255. So where is the wrong? हाँ आता है. Exactly. So we will not have up to 250. Up to how much? You will keep them silent, okay? You get it? We have 247. Now 255 is the total range, but we can't have it. If you have 8 bits, 8 bits means total 55, but we can have it because why? Because हमारे आधे बिट्स किस में लगते हैं? आधे बिट्स लगते हैं हमें क्लास बताने में. जब आप क्लास बता रहे हो तब आप सारे बिट्स को 1 नहीं कर सकते जो आप चाहते थे. So this is class E address which is used for future. You getting me? Sure. So the range भी हमें समझ आ गई. So now question is, अगर आपके पास होगा address in the 0 to 126 class A address, 120 and 127 जो आपका है, यानी कि इसमें कौन आ सकता है? जैसे ये आ गया आपका यहाँ पे, मान लीजिए 0, या मान लीजिए मैं लिखूंगा पे 10.1.1.1. This is class A address. Is it or not? Because why is class A address? Because in the beginning we have a 10, right? If it is class A address, I am saying 10.1.1.1. Now what is 10? 1010. ठीक है, 5 6 7 और 8. पहला बिट क्या है? So it is class A address. Rest we have बाइनरी अगर करना चाहते हो ये बाग में है 0 0 0 0 0, ये 8 और 1, फिर इसी तरह से ये, एंड शॉर्ट वी सेड 10.1.1.1. अब मसला ये है इसमें कि ये 0 तो मुझे बताएगा कि भैया ये कौन सा क्लास है। उसके बाद निकालना ना इन बिट्स में कि कौन होस्ट आईडी है और कौन नेट आईडी है। बात मेरी समझिए। अब ये इंपॉर्टेंट, बहुत इंपॉर्टेंट पॉइंट है। If you want to have a networking subject and you want to become a networking engineer, this is the first thing when you set up a network you need to know. That's what's called subnetting. उससे पहले कि हम सबनेटिंग करें, हम पहले सबनेट मास्क सीखते हैं कि मतलब ये कि we'll learn about subnet mask.
सर जैसे हमने 127 इसमें रिजर्व रखा ना एक क्लास में, सर ऐसे हम बी सी उनमें भी एक एक रिजर्व रखते हैं।
नो नो नो, 127 जो आपका है वो खाली एक चीज़ है, वो अभी दिखाऊंगा आपको। दैट इज यूज फॉर टेस्टिंग, लूप बैक, इसे कहते हैं लूप बैक। हम पिंग इसको करते हैं, वी सेंड द पैकेट विद 127, इफ इट कम्स बैक उसका मतलब हो गया कि आपका जो होस्ट है ये अलाइव है, इसमें टीसीपी आईपी सॉफ्टवेयर लोड है। इट इज फॉर टेस्टिंग ऑफ द यूर, इफ द पैकेट्स आर नॉट लॉस्ट, दैट मीन्स जो आपका ये खुद का जो नेटवर्क अडेप्टर है, ठीक है, ये काम कर रहा है। बात समझ आती है? इट इज फॉर टेस्टिंग ऑफ योर कि आपके पास क्या आप आर यू अलाइव और नॉट, यू कैन से लाइक दैट। आई विल शो यू हाउ टू डू दैट इन ए मिनट। फर्स्ट लेट्स अंडरस्टैंड अबाउट फ्यू थिंग्स। अच्छा, मैं सबनेट मास्क की बात करता, मैं ये बहुत बता रहा था आपको क्योंकि अब मेरे पास जो, अगर आप ये क्लास ए एड्रेस देखेंगे, मैंने कहा 10.1.1.1 ये क्लास ए एड्रेस है। बेसिकली इट इज 4 ऑक्टेट्स, राइट। Subnetting is very easy for you guys. This is not a big thing. It's very easy for you guys. You have done all that. Okay. इसमें तो मैंने मुझे पता है, अगर क्लास ए वाला है तो इसमें पहली बिट मुझे बताएगी कि ये कौन सा क्लास है, ठीक है। लेकिन अब मुझे दो चीजें निकालनी है कि होस्ट आईडी क्या है और नेट आईडी क्या है, ठीक है। अगर वह क्लास ए है, जो नेटवर्क आपको के लिए ऑक्टेट्स है, तो एक ऑक्टेट कितना, द फर्स्ट ऑक्टेट मीन्स 8 बिट्स। दीज 8 बिट्स आर यूज्ड फॉर योर नेट आईडी एंड रेस्ट ऑफ दिस होल इज यूज्ड फॉर दिस और होस्ट, ठीक है। तो ये सारी की सारी बिट्स आपको होस्ट को रिप्रेजेंट करने के लिए लगेंगी। सो यू हैव अ ह्यूज अराउंड 16 मिलियन होस्ट्स, बिकॉज वी हैव हाउ मच, अगर आपके पास 8 बिट्स यहां पे हैं, हाउ मेनी बिट्स आर इन द होस्ट पार्ट, बाकी तो सारी, हाउ मेनी, 24 bits. So 2 to the power 24 hosts you can have, and 2 to the power 8 networks you can have, but not exactly, because some bits will be used for control purpose. But in the general way I will say now 2 to the power 8 networks you can have, and 2 to the power 24 hosts you have. If you have CCNA exam, there you will be asked like, okay, we have in a CCNA we have 2 papers, okay, ICND1 and ICN2. देयर यू विल बी आस्क्ड कि कितने बिट्स एग्जैक्टली, क्या रेंज क्या होगी, कितने बिट्स का ये है, और यू गेटिंग मी। लेकिन जब ये पैकेट आ रहा है राउटर के पास, ये बात समझने की है, ठीक है। अब ये तो बाइनरी में आएगा, अब कितने बिट्स हो, क्योंकि राउटर को तो होस्ट को कुछ करना नहीं। बात समझ आती है? यहां मेरी बात सुनो, पहले मैं क्लास ए की बात कर रहा था, क्लास बी की बात करता हूं। पहले क्लास बी में हम क्या करते हैं काम, क्लास बी में 4 में से हम 2 बिट्स रखते हैं फॉर, मैं जो कलर कर रहा हूं वो फॉर नेट आईडी है, ठीक है। नेटवर्क को आइडेंटिफाई करने के लिए 2 बिट्स लगती हैं, कितनी, और 2 बिट्स जो आपकी हैं इट इज फॉर होस्ट आईडी। और क्लास सी जो है उसमें 3 बिट्स आपको नेटवर्क और 1 बिट आपका होस्ट। These 3 bits are used for network ID and 1 byte. Okay, 3 octets are used for network ID and 1 octet is used for what? The byte, the host. That means 8 bits. That means 2 to the power 8. Right? So how many hosts you can have in a class C address? यानी कि कितने कंप्यूटर आप एंड पे लगा सकते हो, अटैच कर सकते हो, 2 to the power 8, उससे ज़्यादा नहीं, क्योंकि ये बिट्स जो सारी आपकी हैं ये आपको नेटवर्क आइडेंटिफाई करने में लग जाएंगी, 24 बिट्स, ठीक है। उसमें से भी इसमें आधी बिट्स लगेंगी हमें ये आइडेंटिफाई करने की क्लास सी एड्रेस है ना, और 24 में से जो बाकी बिट्स बचती हैं वो बिट्स लगेंगी हमें नेटवर्क आइडेंटिफाई करने में। और 8 बिट्स खाली आपके पास है जो आप होस्ट को एड्रेस दे सकते हो। तो दैट मीन 2 टू द पावर 8, हाउ मच, व्हाट इज 2 टू द पावर 8? 256, 256 में -2, क्योंकि 0 एंड 1 ऑन 1, 0 मीन्स दिस होस्ट एंड 1 ऑन 1 मीन्स ब्रॉडकास्ट, वो इस्तेमाल नहीं होगी। यानी कि 254 कंप्यूटर आप अटैच कर सकते हो अपनी नेटवर्क के साथ, इसके ज्यादा नहीं। अगर आपको अब इससे ज्यादा आपकी कंपनी में 254 जो आपके पास नेटवर्क है वो आप अटैच कर सकते हो, क्योंकि इतने ही होस्ट आपको अलाउड है। यहाँ पे एक आईपी आपके पास दिया गया है, आप उसमें 254 अंदर कर सकते हो। अगर इससे ज्यादा होगी तो क्या करोगे, यही सोचने वाली बात। ठीक है, बात समझ आती है? और 254 को हमने पूरा क्या बस से लगाना है, पूरा एकदम एक ही वायर लगानी है सबको, या सब नेटवर्क्स बनानी है ना? ये सोचने की बात है, क्योंकि आपके कंपनी में अब ऑफिसेज हो सकते हैं, डिपार्टमेंट्स हो सकते हैं। आप कहते हो नहीं ये मुझे 200 कंप्यूटर से मैं 200 कंप्यूटर एक साथ नहीं करूंगा, ये 200 कंप्यूटर मुझे अलग अलग होने चाहिए, लेकिन बाहर दुनिया के लिए एक ही रहना चाहिए। दैट इज व्हाट इज कॉल्ड एग्जैक्टली सबनेट। जो मैंने 2 मीनिंग्स बताए सबनेट के, एक मीनिंग बताया सबनेट का कि आपके पास क्या है, आपके राउटर्स एंड वायर्स हैं एंड एक्सक्लूडिंग द होस्ट, दिस इज कॉल्ड सबनेट। ओके, दूसरा मैंने कहा कि आपको एक नेटवर्क है, जैसे यहाँ पे आपको 254 अलाउड है। 254 मान लीजिए आपके पास 200 कंप्यूटर हैं, 254 ही है, ठीक है। अब 254 आप चाहते हो नहीं, मैं मुझे क्या हो जाए 100 कंप्यूटर इस डिपार्टमेंट के, ठीक है, 50 कंप्यूटर इस डिपार्टमेंट के, 30 इस डिपार्टमेंट के, लाइक दैट। सो आप सबनेट्स कर रहे हो, क्या कर रहे हो, यानी कि अंदर इसके, लेकिन बाहर दुनिया के लिए वो मैं समझाऊंगा अभी आपको, ठीक है। अच्छा, यहां बात आप सुने मेरी, मैं क्या बोल रहा हूं। तो क्लास डी एंड क्लास ई में वहां ये मान्य नहीं रखता क्योंकि वहां जो है वो क्लास डी फॉर द मल्टीकास्ट है और क्लास सी द फ्यूचर यूज है, उसमें ये चीज माने देयर इज नो यूज ऑफ दीज थिंग्स, नेट आईडी एंड होस्ट आईडी एंड ऑल, राइट। सो क्लास सी में कितने बिट्स आपको लगती हैं इसके लिए, नेटवर्क आइडेंटिफाई करने के लिए? 3 ऑक्टस 24। इसमें लेकिन आपके पास एड्रेस आ रहा है, देखिए मेरी बात सुनिए आप, क्लास सी एड्रेस आ रहा है या क्लास ए एड्रेस आ रहा है या क्लास बी एड्रेस आ रहा है, वो आइडेंटिफाई हो जाएगा पहली बिट्स के साथ। अगर आपके साथ 10.1.1.1 आ गया फॉर एग्जांपल, we know this is class A address because it's a 10 in between, in the beginning it will have a 0, the first bit, the most MSB most significant bit will be 0, so it is a class A, no doubt। लेकिन अब उसका मतलब हो गया कि ये जो बंदा है, ये नेटवर्क, ये जो पहला ऑक्टेट है, दिस इज फॉर नेट आईडी एंड द रेस्ट आर फॉर आइडेंटिफाइंग व्हाट, होस्ट, ठीक है। या क्लास सी वाला एड्रेस आ गया, जहां पे हमें पता है कि क्लास सी एड्रेस है, हमें पता है ये तो सारे का सारा नेट आईडी है और ये होस्ट है। अब जो बंदा है, देखिए मेरी बात, ये राउटर एक है, ठीक है, राउटर बोले या रूटर बोले, ओके। इन इफ यू गो फॉर इंग्लैंड स्टफ, यूरोपियन स्टाइल, देन दे से रूटर, इफ यू गो से अमेरिकन स्टाइल, दे से राउटर। It's you what you gonna do. It's not both way you can say. Anyway, this is a router. Listen now. And say another router for example. And इस राउटर के साथ हमें अटैच है, मान लीजिए फिर कोई नेटवर्क यहाँ पे अटैच है, whatever. We have some sort of this, or this is a maybe hub. In this is a connect है. जब ये राउटर आता है, listen, इस राउटर के पास ये आ गया, ये एड्रेस पैकेट विद दिस एड्रेस, आईपी एड्रेस। अब मुझे पता है ये तो क्लास ए है, क्लास ए में ये नेट आईडी है और ये होस्ट आईडी है, ये मतलब ये होगा एड्रेस किसी इस कंप्यूटर के बंदे का। इसको क्या उस कंप्यूटर के बंदे के साथ कोई करना है, ये इंटरेस्ट है, खाली रास्ता कहां से बात समझ आ रही है। मैं आपको चिट्ठी भेज रहा हूं, मैं चिट्ठी भेज रहा हूं अमेरिका से, हमें चिट्ठी आ रही है मेरे घर, इस घर में, इट इज सेइंग इंडिया, देन इट इज सेइंग JNK। जो बंदा बैठा होगा इंटरनेशनल पोस्ट ऑफिस, जब इंटरनेशनल से कोई पोस्ट आता है फॉर एग्जांपल, वहां पे पोस्ट ऑफिस होगा, उसको की करना हाउस नंबर 44 का, उसको कुछ करना है 44 का, ठीक है। उसको तो खाली ये करना है कि भैया इट शुड गो टू द इंडिया, ही इज ओनली इंटरेस्टेड इन इंडिया, इज इट, एंड देन इट गोज फर्दर, ही इज ओनली इंटरेस्टेड इन इंडिया श्रीनगर एड्रेस पार्ट, okay, are you getting me? सो यानी कि ये राउटर जो यहां पे है, ये इंटरेस्ट नहीं है होस्ट के साथ, ये नेट आईडी के साथ। तो इस एड्रेस में से मैं कैसे ये नेट आईडी निकालूं खाली, बाकी को जाने दूं? इट इज कॉल्ड ए सबनेट मास्क। इट इज कॉल्ड व्हाट? नाउ इन अ CCNA exam, it is all about these things. The beginning you go by these things, then it was switching, routing, and also, but this is the actual thing what we read there, and there will be questions from this. Subnet mask, sorry, I said submask, it should be subnet mask. So subnet mask means कि out of this address will get out what? The network ID, okay, and leave about the host ID, because the router जो आपका है उसको host ID से कुछ करना नहीं, वो चाहता है कि इसको आगे कहाँ मुझे धकेलना है ना? जब इसको नेटवर्क का एड्रेस मिल जाएगा उसको पता चलेगा कि मुझे कहाँ भेजना है, इसको किस राउट में भेजना है। बात समझ आ रही है? सिंपल बात है, कंफ्यूजन है बता दो। अब अगर मेरे पास क्लास आईडी क्लास ए है ना, वाई ऐसे ही मास्क, मास्क मीन समथिंग छुपा देना, मास्क मीन समथिंग व्हाट? जस्ट टू हाइड। I want to hide these. If you could tell me, I want to hide what? I want to hide these, and I want to get only this out of it. मैं कैसे करूंगा? मैं सिंपल एंड करूंगा। एंड ला मेरे पास है, 3 साल पहले हम पढ़ चुके हैं, 20 साल पहले की कहानी, कि अगर आपको कोई बंदा है, जैसे अगर आपको 1 है, एंड करते हो किसी ए के साथ, ठीक है, तो जनाब अगर ए 0 होगा तो आंसर 0 होगा, अगर ए 1 होगा तो आंसर 1 होगा। यानी कि अगर ए को आप एंड करोगे 1 के साथ वो वापस ए ही निकलेगा, लेकिन अगर ए को एंड करोगे 0 के साथ, चाहे ए कुछ भी हो वो 0 निकलेगा। तो अगर आप इस ए को हाइड करना चाहते हो कि बंदा 1 है या कुछ है, आप 0 आउट करना चाहते हो, इसको एंड करो 0 के साथ, और अगर आप चाहते हो कि नहीं यही बाहर निकले तो 1 के साथ एंड करो। सिंपल एंड ला जो हम कर चुके हैं, ठीक है, जमाना गुज़श्ता में। हिम्मत है क्यों? वी हैव टू कंप्लीट दिस टॉपिक टुडे, ओके? Now listen what I'm saying. I will give you 2 minutes break, but before this I would like to do this. What I'm saying, how to get it out. Now we know we have the octets. How many octets we have now in IP? Octet कितने बिट्स का होता है भाई? नहीं, ये कितने बिट्स का होता है IP एड्रेस? मैं अब ऑक्टेट्स अलग अलग दिखा रहा हूं, ठीक है? ऑक्टेट मीन्स 8 बिट्स ना, और मुझे पता अगर क्लास ए एड्रेस है बंदा, ये सारा फजूल है राउटर के लिए, क्योंकि ये सारा बताता है होस्ट आईडी। मुझे तो चाहिए नहीं, मुझे नेट आईडी चाहिए। नेट आईडी में मुझे चाहिए खाली ये एड्रेस, और ये मैं मास्क करना चाहता हूँ। तो इनको मैं क्या करूँगा सबके साथ? मैं इसको एंड करूँगी के साथ 0, 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8, 1 2 3 4 5 6। जब आपने क्या हो गया? अच्छा, जब आपने इन सब को ना 0 के साथ एंड कराया, ठीक है जनाब, आप इन सब को 0 के साथ एंड करा रहे हो, आउटपुट की अंदर कख नहीं, ठीक है, आपको तो कुछ नहीं आएगा ना, 0 आएगा, यानी कि ये खत्म हो गया। लेकिन ये तो मेरे को चाहिए, इसको एंड किसी से कराऊंगा, यानी कि 8 1। तो तुम में से कौन बताएगा 8 1 का डेसिमल क्या आएगा? 256। अगर आप डेसिमल नोटेशन कर रहे हो, अब आप डेसिमल नोटेशन कर रहे हो, तो सिंपल चीज ये है कि अगर वो 10.1.1.1 है और आपने आइडेंटिफाई किया ये बंदा तो कौन है? क्लास ए का, ठीक है, तो आप एक काम करो भैया, इसको सबनेट करो, सबनेट मास्क करो 255.0.0.0, क्योंकि 255 ही होता है ना, ठीक है। 255 के साथ करो .0.0। अब उससे क्या होगा? ये दरअसल ये इसका मतलब क्या? सारे 1, इसका मतलब क्या? सारे 0 सारे 0, यानी कि सारे 0 0, ये खत्म हो जाएगा, ये आउटपुट निकलेगा 0 0 0, और ये क्या निकलेगा वापस 10। डू यू गॉट इट? ये 10 निकलेगा या नहीं निकलेगा? क्यों? क्योंकि अगर आपको से 10 था, 1 2 3 1 0 1 0 इज 10 है, 5 6 7 8। जब आप इसको सब 1 के साथ एंड कर रहे हो, व्हाट विल बी आउटपुट? एंड करो सिंपली, ओके, बिट वाइज एंड, हर एक बिट के साथ एंड करो, ठीक है, वो तो वही निकलेगा ना। जब आप 1 के साथ एंड कर रहे हो वही निकलेगा, वो तो मैं बता चुका हूँ कि अगर आप 1 के साथ एंड करोगे, 1 के साथ एंड करोगे ए को, वो ए ही निकलेगा। जैसे आप यहाँ देख रहे हो 0 + 1 is 0 and 0 1 and 1 is 1 and is 1 and 0 and 1 is 0 and so on। ये तो वही निकलेगा कि 10। इसी में तो मैं इंटरेस्ट हूँ, राउटर तो इसी में इंटरेस्ट है, उसको की करना, उसका किसका, रेस्ट का तो वो इंटरेस्ट है नहीं। अब अगर क्लास बी होगा तो आप इंटेलिजेंटली आप बता दो, क्लास बी आपके पास है, क्लास बी में हमें पता है कि 2 जो ऑक्टेट्स हैं वो लगते हैं नेट के लिए, 2 लगते हैं होस्ट के लिए। तो इसका सबनेट मास्क क्या होगा? डेसिमल में बताओ, डेसिमल में। आप इसको भी 255, इससे ये बराबर वही आएगा वापस, ठीक है। अगर मैं यहां पे लिखता हूं से फॉर एग्जांपल 103, क्या ये क्लास बी एड्रेस है? इट शुड बी ग्रेटर देन 127। सो से फॉर एग्जांपल दिस इज 128.4.5.0। ये 4 5 0 गया, ये 5 0 गया पानी में, इसको 0 0 निकलेगा। इन दोनों की जगह क्या निकलेगा? 128.4। यानी कि मैंने इनको मास्क किया और निकाला कौन? हु विल बी इंटरेस्टेड इन दिस? ए राउटर, बिकॉज हु वांट टू सी द पाथ। जब ये होम राउटर के पास पहुंचेगा और ए स्विच इज देयर, वो तो पहुंच गया पैकेट उधर। अब वो इस नेटवर्क में इंटरेस्ट नहीं होगा ना, वो किस में होगा? वो इस साइड को मास्क करेगा, इस साइड को निकालेगा। बट इट अगेन डिपेंड्स अपॉन कि किसको मास्क करना है, किसको मास्क नहीं करना है, डिपेंडिंग अपॉन द क्लास, डिपेंडिंग अपॉन व्हाट, ठीक है। क्योंकि क्लास मुझे बताएगा कि कितने बिट्स नेट आईडी है, कितने बिट होस्ट आईडी है। क्योंकि अगर क्लास सी है आपका, ठीक है, क्लास सी अगर आपका है, उसमें कितने बिट्स मैंने कहा लगते हैं इन द नेट आईडी, एंड होस्ट आईडी सिर्फ 1 बिट, ठीक है। यानी कि मुझे क्या करना पड़ेगा? दिस विल बी द मास्क। व्हाट मास्क इट इज? इट्स कॉल्ड नेचुरल मास्क। इट्स कॉल्ड व्हाट? ये फिक्स्ड है, हमें पता है क्लास सी है तो उसको पास, हमें 3 जो है ये नेटवर्क है, ये होस्ट है, इसलिए इनको मास्क, इसको मास्क करो और ये निकालो। ये समझ आ रहा है? 250 क्यों लिख रहा हूं मैं? 250 दरअसल मीन्स ऑल वंस, एंड विद ऑल वंस मीन्स दैट थिंग, इट विल कम बैक, हमें वही आएगा आंसर। यू गेटिंग मी? आई विल गिव यू सम 2-3 minutes break, okay? I'm also getting exhausted, but we'll come it, we'll fix it, we'll see what is subnetting now. This is subnet mask. Now we have to do subnetting. Okay, we will do it subnetting tomorrow, okay? Okay, we'll continue this tomorrow. We'll read the subnetting. We'll read also the what's called as then the advanced subnetting. Wait a second. Listen here what I'm saying. I'm saying something perhaps. So one is called subnetting, right? We will do it tomorrow, and also that's called variable subnetting. Okay? Variable length subnet mask. We have read VLSI, very large integration, but it's not that. It is VLSM, variable length subnet mask. But I will see if I will teach you or not. This is same. Okay, I will teach you, no problem. Right? Then we will see what is there. Okay? So tomorrow, inshallah.